Alright, this video is to give you a head start or a little boost and point out some things you'll need to know about your alternate assessment for the fourth marking period on graphs of sine, cosine, and tangent. So the first pages start out with a table where I've given you some x values and asked you to find the y values. These are all in radians, and so make sure, first of all, that your calculator is in radian mode. Okay. They very well might be in degree mode right now. Okay, make sure you press the mode button. All right, that's how you get to the screen. And then make sure that radian is highlighted. So in my case, if my calculator is not in radian mode, I'm going to just move the cursor to radian, press enter to make sure that the calculator is in radian mode. You are going to get completely bogus data if you do not take this step. Okay, so the directions are: using a calculator, find the function values for the given angles. Make sure your calculator is in radian mode. Round to the nearest tenth. All right, so back to the home screen. I am going to do the sine of -3, and then pi is, oops, you can't see it. Let me move my calculator. Pi is right here on the calculator. It is above the caret key.
Robert Carter, please come to the main office. Robert Carter.
So it's a second function. So you're going to press second pi. Okay. There it is. It says on the calculator sine of -3 pi. And that says 0. So we're just going to log a 0 on the table. And I'm going to do it again. Sine of -11 pi over 4. That's negative. I'm asked to round to the nearest tenth. -0.7. So I've got -0.7. All right. So you're going to continue this for all of the tables. Sorry, I'm taking so long here. I'm going to zoom out. I want to show you. I'm going to plot those points on your graph. Okay. So my table said that at -3 pi, here's my -3 pi, okay, the x coordinate is -3 pi, the y coordinate is 0. At the next bar, we've got -11 pi over 4. That's the x coordinate. The y coordinate is -7. Now I'm labeled these blocks counting by 2, so that's between -0.6 and -0.8. All right, so here is what my dots look like after I've got them all plotted. I'm going to use the calculator. Okay, and try and get an idea of what the graph looks like. In my y equals screen, I'm going to put sine of x. I better set my windows. I'm going to try and set my windows to make it look like the graph paper. So on my left, I've got -3 pi. When I press enter, it puts it in decimal form. My x max on the right is +3 pi. The x scale, well, each block that as I've set it up on your graph paper is worth pi over 4. Okay? So my x scale, that's how much each block is worth. I have pi over 4. The y min on the paper is about negative 1.3. The y max on the paper is about positive 1.3. And each block on the y-axis is worth 0.2. Okay, so this is a graph of sine from negative 3 pi to positive 3 pi. When you connect your dots, you want to use that image to make yours look as much as you can like the one you see on the graphing calculator. So these are smooth curves. Don't make them pointy. Oh, I missed a dot. Oh, you can't see what I'm doing. Maybe I should zoom out. There we go. Focus. Okay, smooth curves. Okay. So there's your sine curve. I want to point out some things that we've talked about a little bit before, and it's going to start to become more important. The period of sine, okay, is 2 pi. So it's repeating the same thing every 2 pi. It starts at 0, goes to pi over 2, it comes down, goes to negative 1, and then comes back to 0. So this right here is called, from 0 to 2 pi, is called one cycle of the sine wave. Now, I'm not going to show you cosine. Cosine is very much like sine, and you should be able to handle that by yourselves. Tangent. I want to point out some things to you about tangent. Oh, I thought I had my trig card with me. Okay. So, tangent, if you were to look on your trig card, of pi over 2 is undefined. Tangent of 3 pi over 2 is also undefined. Okay, if you look at your trig card, you will see that. All angles that are coterminal with pi over 2 and 3 pi over 2 are undefined. If you use your calculator and you ask for the tangent of pi over 2, it will give you an error. That's because the tangent of pi over 2 is undefined. Okay, so you will see that for all angles coterminal with pi over 2 or 3 pi over 2. Okay, here is my graph that I prepared for you ahead of time. I've plotted points that are on the tangent graph, and I've made these red dotted lines any place your graph is undefined. And those, again, are all the angles that are coterminal with pi over 2 and with 3 pi over 2. Those red lines, by the way, they're called vertical asymptotes, and I'll show you in just a minute how that is going to pertain to my graph. I'm going to graph tangent of x on the same window that I just graphed sine of x between negative 3 pi and positive 3 pi. Right, this graph is confusing. It's very difficult to see what this means, all right? And it's very squished as well. So I'm going to change my windows, and I just want to look at what's happening between negative pi and positive pi and get a better view of this. I'm going to go back to Windows. I'm going to change the x min to negative pi and the x max to positive pi. Okay, and so I want to concentrate on what's happening between the vertical asymptote at negative pi over 2 and at positive pi over 2. Here I've got a continuous curve that is approaching the vertical asymptotes, and that's what the meaning of the vertical asymptote is. That the curve is getting very close to, but not touching the vertical asymptote. If I were to start at the origin, 0, 0, I want to draw a concave up curve that goes through that point and gets close to but does not touch the vertical asymptote. If I go to the left, I've got a concave down curve that goes through that point and gets close to but does not touch the vertical asymptote. That is one cycle of the tangent curve, and so that pattern will repeat between all of your vertical asymptotes. All right, that's it for the video. You're going to have to take the rest yourself. And this, again, is work and alternate assessment. All right, bye.